Thanks everyone for joining. So the topic of today's office hours is the physical migration of an AWS RDS Oracle database to OCI database cloud service or Exadata cloud service using RMAN backups. My name is Marco Calmazzini. I'm a product manager in the backup and recovery team, together with Kelly Smith and Tim Chien, who are also online, and we'll be helping answering questions in the chat or maybe live later if you have other questions. It's going to be a little longer than our usual AskTOM presentations, but I still want to leave some time at the end for you to ask questions, either specifically on this topic or any other backup and recovery related questions or topic you may have. So let's get started. Oops. So first of all, so why would you want to move from RDS to OCI? Well, I mean, there are a number of reasons why you may want to do that. Obviously, OCI, Oracle Cloud Infrastructure, is the best place in the cloud to run an Oracle database. All the Oracle database options are available in OCI. You can run an Oracle database on VM or bare metal, Exadata cloud service. I mean, if you want to use, for example, the performance and availability of an Exadata system, right? It's only in OCI. You can do it in the cloud. You have real application clusters available, and so for these reasons, right, this fact that you have all the options available, etc., it's easier to have hybrid deployments using the Oracle Cloud, where you can easily match what you have on premises. So how then you migrate, right? You can use logical migration methods, and that's still what you have to do if you're migrating to an Oracle autonomous database where you don't have access to RMAN and you can control backups. But if you still want to move to database cloud service type of database, then physical migration may be easier and faster. You just copy the physical data files from RDS to OCI, and now I will show you how to do that. There is a step that you have to take. It's an easy process, but you have to follow the procedure in the right way and with the right order, right? So the process is basically this one. If you start from the left side here, what we are going to do is take an RMAN backup of the AWS RDS instance. Then we will be copying it to the object storage, so to an S3 bucket in AWS. Then we're going to use rclone to copy the content from the AWS S3 bucket to an OCI object storage bucket. And from there, we will use RMAN to restore it into a DBCS, so database cloud service, or Exadata cloud service instance. So let's go one by one how we do that. Starting from the environment we used in this exercise, we used a small instance, RDS instance, 19 version 2020, January 2020 image. It's a non-CDB instance, and that's one of the things that we will have to take care of when we migrate to XSCS or DBCS. We use the S3 integration option group. I will point you to the right place in the AWS documentation on how to do that, but that's something that we will have to do. And then the parameter group is just the default one. It's a small instance, as I said, but clearly the process is exactly the same no matter what the size it is. And on the storage side, we had encryption enabled, which in this case for AWS means just storage encryption. It's not TDE. You can enable TDE on AWS if you want, but if you do that on RDS, it will be RDS managing the wallet. So it's going to be complicated for you to restore the database somewhere else because you will not be able to get the decryption or the encryption master key if you want out of the wallet to copy it to the destination instance. So if you have a TDE encrypted in AWS and it's RDS, then you probably have to clone that database on another RDS and decrypt it. And once it's encrypted, obviously you can go ahead and do that. On the database cloud service side, we were just, as Michael saw here, a small VM standard 2.1 of virtual machine image with Oracle Database 19. 19.6 version here. Also, we had the January patch installed. And we had TDE encryption clearly here because it's mandatory on OCI. And also we have multi-tenant because it's mandatory also in OCI. If you are preparing this destination instance specifically for this purpose, when you set it up, make sure you don't use either as an instance name or as the name of the first PDB that you have to create when you start, or when you create the instance. Make sure you don't use the same name of the AWS instance. Otherwise, you would have then difficulties in importing it. You have to change the names, etc. So if you, assuming you are creating this OCI instance specifically for this purpose, use different names. Also for both for the CDB and the first PDB. And then when we import, we will import the RDS database as a PDB here. We will keep the same name we had on the AWS side. Okay, so this is the environment we used. So going straight into the process for doing this, the first thing that you have to do is prepare the AWS instance. So in AWS, you don't have access to the underlying operating system. You don't have access to RMAN. You don't have access to a user with SysDBA privileges. So all the operation you are going to do on the AWS side will go through the AWS tooling, most of which is through the SQL, not most, all of it is through the SQL Plus interface. So it's just a set of PL SQL scripts, basically, that we will be using. So the first RMAN backup we will gonna take through this will go to a local block storage. Or it's an RMAN backup to disk on the local block storage on the RDS instance. The backups that are configured in RDS as automatic backups cannot be used directly because, again, you don't have access to them, and they are based on snapshots. They're not just full RMAN backups. So even if you have AWS RDS automated backup configured, you cannot use them. So we're going to take a specific RMAN backup for doing that. So to do that, first you prepare the location on the local file system, on the local block storage, where that backup will be sent to. And you do that using the RDS admin util PL secret package. There is a create directory option where you just specify a directory name. In this case, we called it backup. Okay. So this one will create the location on the local block storage to host the RMAN backup. The other thing you have to do, if you haven't done it, probably you haven't if you're not using RMAN regularly, enable the archive log retention. I used 48 hours here. You have to do that. If you don't do that, the RMAN backup will not work. Okay, it will just say PL SQL script completed successfully when you start it, but it just doesn't do anything. So enable the archive log retention with this set configuration script, and then you're okay. The link down here points you to the RDS documentation where it explains how to do these things. But in the end, it's just 2 simple steps and you're good. The other thing that you have to do, it's a little longer, but you can do it on the console, is enable the RDS to S3 integration if you haven't done it before. This is because the next step that we will do after the backup is copy that backup from the RDS instance to the S3 bucket. So it means that the RDS instance must have the privileges to write to the S3 bucket that we want to use. And so for this reason, you have to go through this documentation. I don't go through all the steps here. It's a lot of point and click well, not a lot, but a few point and click in the RDS console and in the IAM console. in AWS, but this is the link to the documentation where it's clearly explained how to do that. Basically, after you created the bucket, you create an IAM policy to allow the RDS service to access the S3 bucket, create an IAM role, associate this IAM role with the RDS instance, and then associate the RDS instance with the option group, including the S3 integration option. This is already there. And that's why, as I showed in the previous screen when I showed the environment, we had that option group that had the S3 integration configured. Okay. So once you've done that, you're basically ready to go and take a full backup. And again, you don't have access to RMAN, but there is this RDS admin package that has the RMAN util backup database full script available. So you specify a few parameters here, like the backup owner, the directory name. Again, this is the directory we created previously. If you remember, we created this backup directory location. You set the include archive logs true because we want the archive logs in there. And then you can specify the number of parallel channels that you want to use. If you want to use compression, if you set it to true, it's going to be basic compression. There is no other option. Either it's true equals basic or no compression. You can set a section size if you want, but this is the full. This is an optional. And you set this output to the BMS false. If you set it to false, the output of this will go to a log destination that I will show you later how to find out what it is. So you run this utility. This will take a backup, including the archive logs, to the local disk in the location we created before. At the end, if you want to see what your backups are and what they are, you can do a select from this table, which is basically a way of listing the content of the backup directory. And here you get the list of the backup. And these are the backup pieces. I just listed 2 of them. There were 8 in total. Again, it's a small database in my case. And these are the backup piece handles, right? The object names, the backup piece names, and where they are, and sorry, the type and the file size. Okay. So once the backup is completed successfully, the next step is copy that backup to the S3 bucket so we can extract it from there, because otherwise we cannot copy those in any other place. So you run this kind of virtual select, right? And you do a select on this RS admin S3 tasks upload to S3, specifying the bucket name where you want to go. Obviously, this is the bucket that you associated, that you gave privileges to the RDS instance to write into. Okay? You can specify a prefix. In this case, we don't specify anything. We want to copy all the content. If there is only some things that we want to copy, then you can use it. But in our case, I'm assuming we created this bucket for this purpose, and there's nothing else in there. So we're going to copy everything. And also, we don't want to add any prefix in front of it. So we just copy with the same name the file from the backup directory on local disk to the S3 bucket, and it becomes an S3 object in the bucket. And the directory name, clearly, what we want to copy from is, again, our backup location. You run this select, start the copy process. We'll return a task ID here. Okay, this task ID can be used to check the result. If you want, right here from SQL Plus, just run a select from, again, this table, which is read text file. The bdump directory is the directory where the RDS instance writes all its logs. This is, for one, the default for all the RDS instances. And the file you want to read is called dbtask dash the task ID returned by the previous select .log. Okay, so this would read this file and basically show you the content of the file there. Again, this is the link to the RDS documentation that explains how to configure the integration and how to use this upload command. But it's really pretty much it. There's not much else to do. This is the other place where you can look at the result of this operation, and also you can look at the log for your backup. It's a log page in the RDS instance console. Okay, so you go to your RDS, the AWS console, you go to the RDS service, you select the database instance you are copying from, and then you go to logs and you see this page. You will see recent events, and among recent events, you will see the task upload to S3 started and the task completed with status succeeded. So it means that everything has been copied successfully. And the other thing you can look at here is your RMAN output, right? In the logs here, as mentioned, this is the content of that bdump directory, right? There's a lot of, it has all the traces and alert log. There's a lot of content here, but you can filter and use RMAN, and it will show you the these text files, which is actually the output of our RMAN commands. So you just select it and click on view, and it will show you really the RMAN transcript. You will see it's a regular RMAN transcript. So you can check that also the backup was successful, right? When you're done, you can do another thing. If you want to check what's really the catalog content, right? Again, you don't have access to RMAN. You cannot do a list backup. But what you can do this select from the $v backup piece view on the Oracle database, and it will list you the file handles, all your backup pieces. Okay? Make a note of the backup piece names. You don't need the directory name here, but we will need later in the process all the backup piece names. So make a list of these handles and save them in a notepad, because we will use them later. Once this is done, we're pretty much done with the RDS instance. There's nothing else we have to do there. We have our backups. We took the backup, we copied to S3, and that's it. We're now ready to copy or extract those backup pieces from the S3 environment, from the S3 bucket, and send it to OCI. You can follow this blog post again. I don't go through all the details again, but the point is you can use rclone, which is an available tool that you can download for rclone.org that works very well for copying objects from one location to another, in this case from an S3 bucket to an OCI bucket. It is, again, as I mentioned, described on this blog post. This blog post linked here was specifically for moving backups from S3 to OCI, meaning that the objects stored in the S3 bucket that we worked with in this blog post were already in an RMAN format. In our case, in an RMAN to cloud format. In our case, they're RMAN to disk format. So there is one thing more that we have to do before we can restore, but the process of copying them over is exactly the same. Remember to disable the automatic backups if you have them enabled on the DBCS instance you created. For the time being, we can re-enable them at the end. And then we will install the database backup cloud module for OCI. Again, you can find how to do that with the instruction in this blog post or the official documentation. In this example, we assume we manually installed the database backup cloud module, and we will use this location for the library, home Oracle OCI lib, and then we will use this name for the configuration file, home Oracle database-2.cfg. It's, again, pretty straightforward. If you're familiar with the database backup cloud module, you probably already understand what I'm talking about. If you don't, take a look at this blog post, take a look at the documentation. It's nothing particularly complicated. Once the copy is completed, we are ready to start restoring. So the next step we were going to do is we connect to the DBCS or XSCS instance, and we change the Oracle SID. We will, set the Oracle SID environment variable to the RDS database SID, okay, the instance name. We do that, and we start RMAN with just RMAN target slash. It will connect to the dummy instance. Okay, there is nothing existing yet for this. So it connect to a dummy instance. We start up in no mount mode. We set the DB ID equals to the DB ID we had in RDS. If you don't remember what it is, just look at the list of backup handles, so backup piece handles that I asked you to comment. And obviously, the first number after the C dash on the control file and SP file or a backup, that's the SID. Sorry, that's the DB ID of the instance. So just this is what you have to do to set the DB ID. Once this is done, the first thing we will do directly in RMAN in terms of running RMAN commands is that step that I mentioned. As there's these backup pieces, as these objects were not created by RMAN as a backup to cloud object storage directly through the SBT interface, but they were instead created as local disk backups using the disk interface. We have to do this conversion. RMAN can do that for us. So you have to allocate a channel using the SBT library in the location we used when we installed the module, and using the configuration file database-2.cfg that was created by the installer when we run the installer, right? We specified this name, so the installer will put all the configuration information into this file. So we started with this, so RMAN will know that it has to point to this bucket that we used as a target when we copy the information. And then we do the send channel J1 export backup piece and the backup piece name. And we will do this for all the backup pieces. This will let RMAN convert this backup. It is done by basically creating some XML files that contain the metadata that RMAN needs when we will do the restore. That's basically it. When that is done, we will be able to restore. Again, you can look at those posts for more details on how to do that. But again, there's not much else you have to do. Just do this send channel, export backup piece name for all your backup pieces, and RMAN will do the conversion. Once this is done, we are actually ready to restore directly from that backup. We can use those backup pieces for restore from RMAN. How we do that? Again, we are in no mount mode, so we needed the run block again, allocate the channel, same SBT library, same configuration file. We just do a restore SB file to a temporary location, and from the backup piece name, that is basically the control file out of backup, the C dash. Okay. Do the restore, SB file restore to this location. We go to SQL Plus, we convert the SP file to a P file so we can edit it, and we can shut down the instance for now. Edit the P file, there are a few changes to do there. Delete the SP file line because that SP file is not there. Note the control file location, the data file names, data file location, the audit location, log file location, everything, file names, everything, and prepare the environment. In this case, to make things simpler, we'll just restore using the same paths that we had in the RDS. So the other thing you have to do is that make sure you have enough space on disk to restore this. But obviously, if you want to set up this database there, you need the space, right? So prepare the environment and then copy the P file to the $Oracle home DBS init sid.ora location using this name. Okay, once this is done, do your startup no mount again. It will pick up this configuration from the P file, and then we're ready to restore. First thing we're going to restore as usual is the control file. So do a restore control file again from the control file or a backup piece. This will restore to the control file location specified in the configuration. So you don't have to specify two. We just go and restore the control file where it was originally. Okay. And once the control file is restored, you can do start a mount. And yeah, we go in mount mode and ready to proceed. At this point, as you can see, it's really a regular restore from an RMAN backup to a new instance, to a new host, for example. So we will configure the RMAN channel pointing to the libopc library, and again, the configuration file we used before. And we set the configure default device type to SPT tape. Okay, this is not necessary if you keep using the device type SPT in your command. But at this point, we are ready to catalog the backup pieces. We want now to import the information about this backup in the control file. The control file only knows about these backup pieces, but it still thinks they were on local disk, not in the cloud. That's where these backups were originally taken on the RDS side. So that's the information, the catalog information that was stored in the control file. And now they are in a different location as backup pieces. So what we're going to do, we do the catalog of these backup pieces, and then we do a cross-check backup and delete backup database and delete the expired backups. So basically, we're cleaning up the information from the old backups from the control file. We only keep the current ones that we have in the cloud. And once, okay, at this point, we can just go ahead and restore database. Do restore database, recover database until available redo, and that will restore all the data files and recover the data files on our DBCS instance, still in the same location they were, still as a non-CDB, just as a standalone non-CDB instance. And obviously, they're not ED encrypted. They were not ED encrypted originally, so they're still not ED encrypted. So there are a few more things that we have to do to make this database something that we can really use as a DBCS supported database. And those two things are adopting it as a PDB in the CDB and encrypting it. So once the restore and recover is done, we can shut down the instance that here, and we are ready to proceed. We started in read-only mode. That's why we shut it down. And we ran the described procedure, the described PL SQL script to create the manifest XML files for this non-CDB database, because this is what we will use to verify it, to check that it's compatible as a PDB, and also to create the PDB in the CDB. So we ran this described, and we create this manifest file. We assume we call it AWS ORCL, which is the instance name, .xml. Okay. Once this is done, you can shut it down. You can shut down this RDS instance, and you connect to the CDB at this point. So you put back the SID as the original SID, the Oracle home. The Oracle SID variable to the original DBCS SID. And you can connect to the CDB database, and you run the check plug compatibility PL SQL script, specifying the manifest file that we created in the previous step. This is all documented in this process on how to convert a non-CDB to a PDB database in 12c. This is the must node. It's all documented there. It's for 12c, but its process is exactly the same for 18 and 19 database. So you run this. This will basically go through this, parse this AWS RCL XML manifest file, and make sure that everything is compatible between the original CDB, non-CDB database and the current CDB, so that it can be adopted. This will write this information, and this PDB underscore plug underscore in underscore violation table or view. I don't know exactly which of the two it is, but basically, this is where the compatibility, yes, no warnings and errors are stored. So you run this select, and you will find what the result of this process is. Very likely you will see a number of warnings. You will definitely some tablespace not encrypted warnings. You can ignore those warnings for now because we will encrypt later. So obviously we would expect those warnings. You will see warnings for database options mismatched. That can also be ignored. All of them should be that some options are present on the CDB, but not on the PDB. Remember, in this case, the PDB is our RDS non-CDB database that we are importing, that we are adopting here. So options are not there, but as long as the PDB has less options than the CDB, we're good. So that would definitely be the case. So that should also be ignored. You may find, I found a time zone version file mismatch. Right? The RDS instance had the time zone file version 34, the CDB as time zone file version 32. If that's the case, although this is a warning, the PDB cannot be opened. So you have to resolve this, even if it's a warning. And you resolve this by going to MOS, looking for time zone 34 patch, and this time zone file is delivered through a patch. So you download the patch and install it, and at that point you have on the CDB time zone version file 34, and you're good to go. You will probably also see errors for patches mismatch. Those must be resolved. You must have the same patch on the PDB and on the CDB. And there's not much else you can do here other than downloading the patch and installing them. So the select before the messages will tell you the patch number, will tell you, oh, this patch is installed on the PDB, but it's not on the CDB. So again, you go to MOS, look for the patch for 19.6.0, 19.6 version. If you're running 19.6, like in my case, obviously you find the one for the right version you're running, and you install it. That's it. Okay. Once you install it, you can try creating obviously the database and all the database. Do the older database, pluggable database open. So you create the pluggable database using the Oracle AWS RCS.xml file that we created with the described script you ran before. If you use a different name, obviously you have to use a different name here. Here we just use copy. This is basically creating the pluggable database, keeping the data files where they are, using the same data files. You can use convert if you want to move the data files to a different place. In my case, I also use a DBCS instance that was using an LVM environment. So also the original cloud OCI instance was just using regular file system for my database. If you're using an ASM location, or if you're using XSCS, where also you have ASM location, clearly you can add a file name convert here, and convert the data files to the ASM location where you want them to, where you want your database to go. And then after that, you can try opening your database with Alter Pluggable Database open. You can do a show PDBs. If it says open, read, write, yes, you're good, everything was fine. But that means that most likely you didn't have issues with patches here. Okay? Because if you had patches, the information of the patch you installed on the CDB is not yet on the PDB, right? So you would still think that PDB is matching, or we still report that PDB is matching, is missing some patches. So what you have to do, if that's the case, you go out to the operating, so you exit SQL Plus, you go to the operating system, you run this data patch.verbose shell script. It's a shell script that basically look at the patches and update all the PDBs to include the information of those patches. That's why you have to do this alter database, pluggable database open anyway. It will be open in restricted mode. You will see a message if you have this mismatch. You will see a message that says open with errors or open with warnings. And again, you do show PDBs, and you would see that this PDB and the restricted as yes, this is open and restricted mode. So this data patch script will fix this, and at that point you can do an all the database open, read write, and you should see this Pagel database portal. And it means that your database is now, your RDS database is now open as a PDB in your DBCS instance. But it's still not encrypted, as you remember. So the last step we have to do is encrypt it. And by doing that, so to do that, you connect to the PDB. So you do order session set container equals your PDB name, and you run the command to create the master key for this PDB in the wallet. So you do administer key management set key using tag and force, whatever tag, yeah, whatever tag you want to use. Force key store identified by password. This password is the wallet password. The wallet password is the same password you use as the sys user password. It's basically the kind of administrative password you specified when you created your DBCS or XCS instance. Okay. So this will create the master key and once for this PDB, and when the master key is created, you are ready to do an order table space, and system is the first one I used. I didn't list all of them. Encryption allowing using AES 128, I use encrypt, and this will start encrypting, doing online encryption. In this case, the system database, you have to encrypt all of them. Okay, so all your table spaces must be encrypted. So you repeat this command for all your table spaces. And once you've done that, you're finished. It's all you have to do. You have successfully physically migrated your RDS database to the Oracle Database Cloud Service using an RMAN backup and restore procedure. Again, I mentioned physically because you can do a logical migration if you want. That is a service, an AWS service. It's called DMS, Data Migration Service, that can be used as an alternative approach, but this uses a logical migration. So you have to create a target database, and then you would just do in a basically physical copy, and then also use log shipping to recreate all the content in your target database. It's not a physical migration. It's more complicated. It's complicated to set up the service. You have to set up the service, and it has associated costs. It's a service that you have to pay for in the AWS. Okay? So again, for this DBCS and XSCS service, this is probably a valid. I mean, the physical migration is probably a better alternative. I mentioned this already, used an LVM target. So the target was also based on local file system, no ASM. But if you have an ASM target or you want to use an ASM target, then you can use a file name conversion when you create the PDB. The recording of this session will be posted as usual on the AskTOM website, so you will be able to go there and review it later. And also this will be described with more details and not more details than when I explained, but more details than that just looking at the slides on a blog post that will be posted on the backup and recovery blogs under the MAA blog groups. And yeah, look at them. There's also other interesting content in there you may want to look at. So I think that is all for this process that we want to share today. We still have a few minutes, more or less 15 minutes or 20 minutes for questions. If anyone had questions or comments, obviously, feel to take the feedbacks and comments live or in the chat. I'm going to look at the chat, and maybe some questions were already answered. So let's see what we have here. Again, if you want to speak, just unmute yourself and feel free to speak up.
Hey, Marco, this is Kelly. There is one question that came up that you might want to talk about real quick, and that is the amount of space that is used as we're creating the backup on disk, moving it to the object storage in Amazon, then moving it to OCI object storage, and then doing the conversion.
Well, the space needed, again, in my case, I created a file system based instance and I moved the database restored as, again, an Oracle file system, and I adopted this PDB without copying the data file. So basically, there is no additional space needed on the target. Clearly, you need some space on the local RDS instance when you do the backup. You need the space for the backup. You can use compression if you want, that may help, but again, you have to make sure your backup fit on that destination. In case you may have to add some, temporary additional block storage on your RDS instance and use that additional block storage as your destination for the backup. Again, on the OCI side, if you use this same approach, so you continue using a file system-based, LVM-based instance, so assuming you go to database cloud service, you may not need any additional space. You need the space for the instance, obviously. That's the space of your database. So if your database is, like I see here in the chat, 18, 20 terabytes, you need space when you create a DBCS instance to contain 18, 20 terabytes database. But you don't need additional space because you keep the files as they are. You do a restore, and then you adopt this database as a PDB using that file. You may need some additional space for the conversion. I think the online, if you use the online table space conversion, it creates temporarily another location, and it moves over time. So it does this behind the scenes, but you have to consider that space. But it's done table space by table space. So you're not doing all at once. So that may not be allowed, but something to probably keep in mind. The other key things to keep in mind is that if you want to use ASM on DBCS, so you create an ASM instance, or you go to XSES where you have to use ASM, then you cannot adopt the PDB keeping the same data files. You have to convert that into an ASM. So you need, in that case, you need more space. But again, it's up to you. It's just a matter of planning. In terms of being feasible, obviously, the larger the database, the longer it takes to copy and move the data over. You may be able to shorten probably a little bit the time by doing a subsequent incremental. So you do your first database, you do your first restore on the OCI side before going through the PDB adoption step on that same temporary local instance, if you want, that we use for restore. You can do, once everything is established, your full restore is done and everything is complete, you can take another incremental on the RDS side, do the same process, copy it over, and then at that point, you shorten the failover switchover time, okay, or the cutoff time by doing only an incremental. That's maybe an option that I didn't cover here. That could be a good suggestion for a follow-up. Okay, there is a question here. Does Oracle Cloud or Exadata gives more scalability? Well, Exadata, I would say definitely yes. I mean, especially in terms of performance, right? It's totally different running a database in the Oracle Cloud, either as a bare metal service, for example, but also as an Exadata cloud service, totally different than running it in a VM in RDS. That's definitely the case.